This will be a quick video on how vector questions can involve ratios. So sometimes the ratios are used to tell you the lengths of different sections of a straight line. So for example, if I have this line and it's defined from the endpoint as, let's say, x, and then I have y here, and then z over here. So instead of the question telling me how much, or let's say this is half of the other length or so on, it's going to use ratio. So it's going to tell me that x, y to yz is equal to 2 to 3. And what this means is, well, you need to think ratio-wise. So as ratios, what it means is that if I have something of it's 5 parts, then xy, let's highlight it, xy will take up 2 parts and yz will take up 3 parts. And this just goes back to the basics of ratios. If I have something worth 10 parts, then xy will just take double of that, so xy will take 4 parts and yz will take 6 of that. So this is what the ratios are. So it just means, so using this idea, it means that xy is, so using vectors, it means xy is 2/5 of yz. And we can use the same logic and say yz, so this whole yz thing is 3/5 of xz. Sorry, this is xz. So we're looking at the whole line. So xy is 2/5 of this whole line, and yz is 3/5 of this whole line, xz. So just to clear the confusion, so this is how you'd use the ratio. Nothing too confusing, so just translate it into words or numbers just to see how it works. So an example of a question that might pop up is such. So we have a parallelogram. We have M being the midpoint of DC. P is located on this line segment A to M. And it tells you that A to P, the AP to PM is equal to 2 to 1. So it's a ratio of 2 to 1. So AP will always be double PM. So that's the idea of it. So using these facts, so let's say if this was a vector A, then this will be double it. So this will be 2A. And that's how the ratio would work. So let's solve just a few examples, and then I'll leave the rest for you to attempt and solve. So if I have, they're giving me that A to B is the vector P, and A to D is the vector Q. Find the vector expressions for D to M. So D to M would be me moving, since this is a parallelogram, be aware that AB is equal to DC, AD is equal to BC. So D to M would be half the distance of D to C, and D to C is equal to A to B. D to M would be half of P. Because if this is P, then this will be P as well. And we're moving until the midpoint, so we know it's the midpoint, so it's half of P. And so this is part I. If I need A to P, A to P would be half the way from A to M. Not half of the way, sorry. It will be, so let's do what we did in the previous slide. A to P would be 2/3 of A to M. So just taking 2 and then 2 plus 1, so that's 3. So 2/3 of A to M, this whole line. And a to m is basically q plus, is just q, and then plus half of p, which is d to m, so half of p. And so I can write this, I can plug this in there and say AP is 2/3 of Q plus half of P, and then you expand it like you would in algebra. So I have 2/3 of Q plus, remember it's multiply, so I have 2/6 of P. And you can try the rest, so I just wanted to show you how it would work with the ratios. Hopefully it's clear. Just use the logic that is used here. Just to be aware, the 5 comes from adding the ratios that you have. So use the logic that we used here to understand and know how to use the ratios. Otherwise, once you understand it, you can just use the first video on vector geometry to be able to understand how we move on between vectors. You can complete the rest of the question as practice.